All right, how are you all? Hope you're doing well. We are going to do the second to last lesson of the unit, which is about solving quadratic. This should say equations, not expressions. So if you could cross that off and change it to equations by completing the square. This whole unit is about solving all sorts of equations, or all sorts of quadratic equations with different methods. Our last method is, our second to last method, excuse me, is by completing the square. Sometimes some equations are not factorable, so by completing the square, we'll be able to actually solve the problems easily without any issues. So if you could take a look at question number 1, we're going to go ahead and figure out how to solve this equation right here. So when you're solving a quadratic equation like this equation right here, normally what we would do is we would subtract 12 from both sides. Actually, I don't want you to write this down, just watch what we're doing, please. So I would normally subtract 12 from both sides, and then I would end up getting x squared plus 6x minus 12 is equal to 0. Then I would try to factor this expression right here, but unfortunately it's not factorable because I cannot find two numbers that multiply together to give me negative 12 and add up to give me 6. So what I would do instead is I would do the process of completing the square. So now if you could start writing this down, we're actually going to be doing the proper method to solving this equation. So if you could write this down, that would be great. So I am just going to complete the square like I normally would do. I would ignore this 12 right here for right now, and I would complete the square on the right side over here. So I would take, just like we've always done, I'm going to take the b value, which is 6, and then I'm going to cut it in half, and then I'm going to square it. So I end up getting 6 over 2, the whole quantity squared, which is 3 squared, which gives me 9. All right. So what I would end up doing right here is I would end up getting, I'm just going to copy the 12 down exactly how I see it. So I'm going to say 12 equals x squared plus 6x. And then I'm going to add the 9 because that will help me complete the square. But if I add the 9 right here, I have to make sure that I subtract the 9 so that these two will cancel each other out. So then, once I'm done doing that, I'm going to complete the square. Excuse me, I already completed the square. I'm going to factor this perfect square trinomial. So this will turn out to be the quantity x plus 3 squared. And then I'm going to copy the rest of the equation down. Now this turns into a problem just like we did a few days ago, I think when you watched video 6 or 7.2. I'm going to isolate this perfect square right here. So I need to get rid of this 9, and the way I would get rid of it is by adding 9 to both sides. So I'm going to add 9 to both sides, and I end up getting 21 equals the quantity x plus 3 squared. Okay, now in order to get rid of the square, I would do the inverse, so I'm going to square root both sides. And do not forget that when you square root a number, you end up getting two possible answers. So this will turn out to be plus or minus the square root of 21 is equal to x plus 3. Okay? Lastly, I need to isolate this x right here. So in order to isolate that x, all I have to do is subtract the 3 from both sides. So my answer ends up being negative 3 plus or minus the square root of 21 is equal to x. This 21 is not divisible by any perfect squares other than 1, so it is completely simplified, which means that this is my final answer. Okay, so I just want to really quickly talk about how to check this answer in your calculator. So if you could open up your calculators, open up a calculator document. And what we're going to do is, since our first answer was negative 3 plus the square root of 21, I'm going to type in negative 3 plus the square root of 21. Make sure to click over so you are no longer in the square root anymore. store it as any variable you want. Since this problem has x's, I'm just going to store it in as x. Then I'm going to press enter. Now when you do this, you would normally type in 12 equals x squared plus 6x, because that's what the equation says. And when I press enter, you would get true. What I want you to do though is sometimes it doesn't always work out this way. Sometimes it says that there's an error because of a problem with the arithmetic, so it approximates your answer. So what I'm going to have you do is just type in each side of your equation separately. The left side of your equation you don't really need to type in because you already know that it's 12. So I'm just going to type in the right side of the equation, which says x squared plus 6x. Once I type that in, I end up getting the same number on the right side as I did on the left side, which means that that worked. But I'm only 50% sure. So now I have to do the same thing with -3 minus the square root of 21. Don't forget to click over, store it in as x, press enter. Then I'm going to go up, highlight this answer right up here, press enter, enter, I still get 12. The number that I want is 12, so I know that it works. Okay, so in question number 2, the problem says 4x squared plus 94 equals 40x. Now, what I want to do is I want to make sure that my ax squared and my bx are all on one side. Because the bx is on the right side, I'm going to get rid of it and put it on the left side by subtracting 40x from both sides. So I end up getting 4x squared minus 40x plus 94 equals 0. It doesn't matter what's on this side. It's just a coincidence that it ended up being 0. Not a coincidence, but it just happened in this example that it ended up being 0. It doesn't always have to be 0. So what I'm going to do is I need to take my ax squared and my bx, but I need to make sure that the ax squared has a leading coefficient of 1. So just like we learned in the last video, factor out a 4 so that this leading coefficient will now become 1. So it becomes 4 times x squared minus 10x. I'm going to leave a little bit of space, plus 94 is equal to 0. Okay? Okay, so now I have to complete the square for what's inside of the parentheses right here. So I'm going to take my b value right here, which is -10, and I'm going to cut it in half, and then I'm going to square it. So I'm going to take -10, divide it by 2, square that, so I end up getting -5. Do not forget to have your parentheses, since that -5 is being squared. It's a negative number, so you always need to have parentheses around it. So I get positive 25. So this number that I'm going to add inside of here is a positive 25. But I'm technically adding the 4 times the 25 right here. So 4 multiplied by 25 is 100. I'm technically adding 100, so over here I need to subtract 100. So now I can factor what's inside of here. This ends up being x minus 5 quantity squared multiplied by 4, and then combine these like terms, I get -6 equals 0. Now my goal is to isolate my perfect square, this x minus 5 squared. So in order to do that, first thing I have to do is add 6 to both sides. So I end up getting 4 times x minus 5 quantity squared equals 6. Then I need to get rid of the 4 by dividing by 4. And 6/4 reduces to 3/2. Now in order to get rid of my perfect square, I need to square root both sides. So I end up getting x minus 5 equals plus or minus square root of 3 over 2. So then I'm going to add 5 to both sides, add 5 to both sides. So my final answer is going to be x equals 5 plus or minus the square root of 3 over 2. Now, although I'm saying it's the final answer, for the purposes of this class, we're going to say it's the final answer. However, when you get into higher level mathematics, you will realize that this is not allowed to be your answer because you have a radical in the denominator, and that's not allowed. So we would do something called rationalizing the denominator. It is not required at all, but if you're interested in what that means, go ahead and Google rationalize the denominator, and you'll be able to quickly and easily understand how to get this to be the actual right answer that we want. Again, not a requirement, but something to do if you're interested. So now it should make sense to you why we did all of this work on completing the square. This will help you to be able to solve quadratic equations using another method. Okay, so I'm going to check my answer just to make sure that I did this correctly. So I'm going to type in my first answer, which was 5 plus the square root of a fraction, 3 over 2. So I'm going to write in 3 over 2. Remember, you can do control divide to get your fraction, so 3 over 2. And that is going to be my x value. So I'm going to control store as x, press enter. Then I'm going to type in the left side of my equation, which is 4x squared plus 94. Press enter. I get this value over here. Now this value means nothing to me at this point in time yet, but I'm going to type in the right side of my equation too. So I end up getting 40x. I'm going to press enter. And then now this number means something to me because when I do it on both sides of my equation, I get the same number. Okay, I'm going to do the same thing with 5 minus radical 3 over 2. So I'm going to take this right here. I just went up. And then I'm going to delete this and make this minus, press enter. And then remember, you can scroll up and highlight the expression again. So the left side of my equation is my first expression, press enter, enter. And do the same thing for this 40x right here, enter, enter. They are the exact same thing on both sides. So I know for sure that both of my answers are correct. And that's it for the video.